Okay, good morning. This is Dr. Sailaja working as Associate Professor of Mathematics, MLR Institute of Technology, Hyderabad. Today we are going to discuss about in large samples another type of test, that is difference of proportions. In the previous class we have discussed if only one sample data is given, how to define null hypothesis and what is the test statistic to apply or to accept or reject the null hypothesis. Now we study about the difference of proportions if two samples data is given. So difference of proportions. Difference of proportions means two samples data is given. Single proportion, only one sample data is given. So in this difference of proportions, again in large samples, n greater than 30, sample size must be greater than 30, two samples we consider. Let the sample sizes of two samples are n1 and n2. n1 greater than 30 and n2 also greater than 30. And here also in the questions, sample proportions will be given. That is small p1 proportion of the first sample and small p2 proportion of the second sample, which is denoted by P1 and P2 respectively, and we calculate these two sample proportions by using P1 equal to x1 by n1 and P2 equal to x2 by n2, where x1 and x2 are number of defective items or articles in those samples. x1 is the number of defective items in the first sample and x2 is the number of defective articles in the second sample, so that we can calculate the sample proportions of both the samples. And here also q1 equal to 1 minus p1 and q2 equal to 1 minus p2, since the total probability P plus Q equal to 1. And the test statistic is Z is equal to P1 minus P2 by under root P1 Q1 by N1 plus P2 Q2 by N2. Here we consider this formula according to the data given in the question. If sample proportions are given, we take small p1 Q1 and small p2 Q2. Population proportions are given, then we consider capital P plus Q equal to 1. So P1 Q1 by N1 plus P2 Q2 by N2. According to the given data, we apply appropriate formula for test statistic. And we define the null hypothesis, that is, these two samples are drawn from the same population or the two population proportions are equal. Suppose the first population proportion is capital P1 and second population proportion is capital P2, then we define the null hypothesis is these two population proportions are equal. That is null hypothesis H0. And alternative hypothesis we define it as two-tailed test, P1 not equal to P2. This is about the procedure to test the null hypothesis of two sample proportions are given. And we can calculate the common sample proportion by using the formula small p equal to n1 p1 plus n2 p2 by n1 plus n2. n1 is size of the first sample, n2 is size of the second sample, p1 is proportion of the first sample, P2 is proportion of the second sample. And here small p is common sample proportion for these two samples. And this under root PQ into 1 by N1 plus 1 by N2 is the standard error of difference of sample proportions. That is standard error of difference of sample proportions, which is denoted by SE of P1 minus P2 and which is given by under root PQ into 1 by N1 plus 1 by N2. And this is a confidence interval. So population proportion lies in which interval? So that is P1 minus P2 minus Z alpha into standard error. This is lower limit. And P1 minus P2 plus Z alpha into standard error. So this is upper limit. Now we consider the examples based on the two samples data. A random sample of 400 men and 600 women are asked whether would they like to have a flyover near their residence. 200 men and 325 women were in favor. Test for significance of difference of proportions at 5% level. Also find standard error and confidence limits. Now we see, first always write the data in mathematical notations. What is the data given? A random sample of 400 men and 600 women. From men population, they have taken 400 men, and from women population, they have taken 600 women. So here men population is the first population, women population is the second population. So size of the first population, men population, that is N1 is equal to 400. Size of the first sample. Size of the second sample, that is denoted by N2, 600. These two samples are greater than 30. So this is large sample data. And moreover, enquiry is, that is whether they have a favored about the flyover near their residence. So out of 400 men, 200 men are favored about the flyover and 325 women are favored about the flyover. So this is number of men X1 equal to 200. They are favored about the proposal. Similarly, X2 is number of women they are favored about the proposal, that is 325 women. So men population is the first population, women population is the second population. So from first population they have taken first sample 400. From second sample they have taken second sample 600. Out of 400, 200 are favored. Out of 600, 325 are favored. So what is the first sample proportion? That is denoted by small p1, which is equal to x1 by n1, and calculate the second sample proportion p2 equal to x2 by n2. So small p1 is x1 by n1, that is 200 by 400, and small p2 is x2 by n2, that is 325 by 600. So p1 equal to 1 by 2 and p2 equal to 0.5416, and we know that the total probability is equal to 1. So small p1 plus q1 equal to 1 and p2 plus q2 equal to 1. So from these equations we can calculate q1 equal to 1 minus p1 and q2 equal to 1 minus p2. So now we find the common sample. For these two samples we find the common proportion, that is denoted by small p, n1 p1 plus n2 p2 by n1 plus n2. So here n1 p1 is 400 into 1 by 2 and n2 p2 is 600 into 5416. So N1 P1 plus N2 P2 by 400 plus 600. These two are sample sizes. So after simplification, we get for both the samples what is the common proportion, that is 0.525. So Q equal to 1 minus P. So this is a sample proportion and this is a Q value 1 minus P. Now we define the null hypothesis is both men and women are equally proportional about the proposal. So H0 is P1 equal to P2 and H1 is P1 not equal to P2. This is a two-tail test. And the standard error of sample proportions is under root PQ into 1 by N1 plus 1 by N2. Here P is 0.525, Q is 0.475 into sample sizes 1 by 400 plus 1 by 600. So this is a standard error. Now the test statistic is Z is equal to P1 minus P2 by standard error. So here Z is equal to P1 minus P2 by under root PQ into 1 by N1 plus 1 by N2. This value we got 0.0323. Under root PQ into 1 by N1 plus 1 by N2. This value 0.0323. So this is 0.5 is first sample proportion. Already we calculated here. First sample proportion is 1 by 2. Second sample proportion is 0.5416. Substitute all these values in test statistic. We get minus 1.24. Here our calculated value is negative, even though we take only modulus value, that is modulus of Z calculated is 1.24. Now Z tabular value is for 5% level of significance two-tail test, that value is 1.96. Now compare both calculated and tabular value, then we get Z calculated is less than Z tabular value. Therefore, we accept null hypothesis at 5% level of significance. There may be 5% error in our null hypothesis or in our claim. What is the claim? Both men and women are equally favored about the proposal. And confidence limits. So here P1 minus P2 is 0.5 minus 0.54. So this value minus Z alpha by 2 is a tabular value 1.96 into standard error is 0.0323. After calculating, this is lower limit, this is upper limit. So lower limit is minus 0.103 and upper limit is 0.023. So this value belongs 1.24. So here 1.24a lies between here in this interval. So we accept a null hypothesis at a 5% level of significance. See the next example. If 45 of 180 transistors of type A and 34 of 120 transistors of type B found to be defective, what can we conclude about the difference of proportions at 5% level of significance? So in the question he asked that test the hypothesis of difference of proportions. So if 45 of 180 transistors, out of 180 transistors, 45 are defective. So here first sample size is N1 equal to 180. Out of 180 transistors, 45 are defective. So X1 value, number of defective transistors are X1, which is 45. So first sample proportion P1 equal to X1 by N1. So 45 by 180, that is 0.25. Similarly, out of 120 transistors, 34 are defective. So number of defective transistors are X2, that is 34, and the sample size is 120, which is denoted by N2, 120. So second sample proportion is denoted by P2, that is X2 by N2. 34 by 120, and that value is 0.283. Now we got a first sample proportion and the second sample proportion. So this is the proportion data is given. Moreover, two samples data is given. That's why we apply Z test for difference of proportions, since two samples data is given. Now we calculate what is the common sample proportion for these two samples. So that is denoted by small p, N1 P1 plus N2 P2 by N1 plus N2. So here this is 45 plus 34 by 180 plus 100, and this value is P equal to 0.263, and calculate Q equal to 1 minus P. Now we define the null hypothesis H0 is P1 equal to P2. That means there are equal number of defective items from both the populations. So from type A or type B. So from these two populations, there are same number of defective items, or these two samples are drawn from the same population. P1 equal to P2. Now alternative hypothesis is P1 not equal to P2, that is two-tailed test. So here Z is equal to P1 minus P2 by under root PQ into 1 by N1 plus 1 by N2. This is standard error of difference of two sample proportions. Which is equal to under root PQ into 1 by N1 plus 1 by N2. This value is, substitute all the values here, small p is 0.263, small q 0.737, since 1 minus p, into 1 by first sample size, 1 by second sample size, which is equal to minus 0.647. So we take a modulus of Z calculated is 0.647, and tabular value at a 5% level of significance for two-tailed test is 1.96. So here calculated value is less than tabular value, therefore we accept a null hypothesis at a 5% level of significance. That is what is our claim. So here the two samples are drawn from the same population. H0 is accepted. Thank you.